Prevent duplicate requests. One of the most common senior-level system design questions, and one where the wrong answer can cost real money. Imagine a user clicks buy now twice in 2 seconds. Both requests reach your payment service. Both get processed. The customer gets charged twice. Or you have a service that calls order service twice. Now the user has 2 orders instead of 1. On top of that, order service calls payment service twice, so now user has duplicate payment. This is the duplicate request problem, and it happens more than you think. The interviewer asks, how do you guarantee a payment is processed exactly once, even if the request is sent multiple times? This can happen in 3 ways. A user double-clicks. A service retries after a timeout. The network retries automatically. Your system needs to handle all 3. Duplicates come from 3 different layers. First, users clicking multiple times. Second, clients retrying after a timeout, not knowing if the first request succeeded. Third, infrastructure like load balancers or service meshes retrying on failure. Any solution needs to cover all 3. The most robust solution is the Idempotency key. The client generates a unique key, usually a UUID, and sends it with every request. The server checks if that key was already processed. If yes, it returns the cached result without charging again. If no, it processes and stores the result. Same key, same outcome, always. Where you store the key matters. Redis gives you speed, a lookup in under 1 millisecond, but it's volatile. If Redis goes down, you could lose key history and process a duplicate. A SQL database is durable, the key survives restarts, but it adds latency. In critical flows like payments, use the database. In high throughput, low risk flows, Redis works well. A simpler approach. Use a database unique constraint on the field that identifies the operation, like order ID. The second insert for the same order ID throws a unique violation. Your service catches that exception and returns a 409 conflict. No custom key needed, but this only works when you control the database schema and the identifier is truly unique per operation. For race conditions, 2 requests arrive at the same time for the same payment. Request 1 gets there first and calls try acquire lock. It asks Redis, is anyone else working on order 001 right now? Redis says no, so request 1 takes the lock. That lock is a flag in Redis that says, this operation is in progress, nobody else touch it. Request 1 processes the payment normally, then calls release lock. It tells Redis, I'm done, the lock is free. Now, when request 1 is in progress, what happened with request 2? Request 2 also calls try acquire lock for the same order, but this time Redis says, lock is already held. Request 2 has 2 options. Wait until the lock is released, or get rejected immediately with a 429 too many requests response. In payment systems, you almost always reject immediately. You don't want a queue of duplicate charges waiting to run. Here's the critical part. Every lock must have a TTL, a time to live. If request 1 crashes mid-process and never calls release lock, the lock stays forever and no future request can proceed. With a TTL, Redis automatically deletes the lock after, say, 5 seconds. The system recovers on its own. Never create a lock without a TTL. Here's how to compare them in the interview. Idempotency keys are the most complete solution. Durable, works across retries and double clicks, but requires more implementation. Database unique constraints are simple and reliable, but only work when you control the schema. Distributed locks handle race conditions, but add operational complexity and risk of deadlock. For complex scenarios, combine idempotency keys with a database constraint. That covers every case. If this helped you think differently about duplicate requests, follow at capacitaDEV on Instagram and TikTok. New senior and staff level content every week. Hit like so this reaches more engineers who are preparing for their next big interview. And if you found this useful, share it with someone on your team. There's also a free PDF in the profile link. 20 real interview questions covering junior, intermediate, senior, and staff levels. Go grab it.